Okay, so here we are with part two of just working with exponential functions. I'm going to get into just some different interest problems, some depreciation, appreciation. I've only got two examples for you, but I'll talk a little bit more about each one. The first one is dealing with money, which is always fun. If you deposit $12,000 into some type of account, whether it be a CD or some type of bond or something, and let's say that it collects 9% and you leave it in there for 5 years, I just wanted to remind you of the compound interest formula, where A is the amount, P is the principal, R is the rate, N is the number of times compounded, and that's per year, the number of times per year, and then T is the time, or number of years. Okay. We've also got the compounded continuously formula. You'll hear me call it the PERT formula, where P is the principal, E is the rational number, 2.718, and it goes on. And then R is the rate, T is the time. Okay, so let's say you've got that $12,000 that is collecting 9% interest, and it's compounded quarterly for 5 years. Then you would just say that A is equal to the principal, 12,000. 1 plus your rate is 9%, so we'll say 0.09. Because it's compounded quarterly, which is 4 times per year, then we're going to say that your N is 4. And that'll be to the 4 times your number of years. Okay, so you could plug that into your calculator and you would end up with $18,000. I'm sorry, $18,726.11. So you made almost $7,000 off of it in 5 years. If you were doing it monthly, you would put 12 in for N. So this would be 0.09 over 12 to the 12 times 5. And you would get $18,788.17. So you get a little bit more because it's compounded more times per year. And then continuously, we would say that we have $12,000 times E to the R times T. And you would plug that into your calculator, and you would get $18,000, 819 and 75 cents. Okay. Now, when you're plugging these into the calculator, you do have to be careful. Like for that first one, this one up here, you would want to plug this in as 12,000, and you could put parentheses 1 plus. You want to make sure you open another set of parentheses and do 0.09 divided by 4, close that, close it again. And then you could use the little caret after that. Sorry, this would go up here. The caret, open parentheses again, then 4 times 5. So if you're plugging this into your calculator and you're not getting the same numbers that I am, that's how you want to plug it in. And that would get it for you. On the continuously formula, you would say 12,000 E, the little caret, open parentheses, 0.09 times 5, close parentheses. Oops, sorry. Keep doing that, don't I? $12,000 times E, caret, 0.09 times 5. And that would give you $18,819.75. Okay, let's look at one more here. I've got a BMW M5 that costs $87,985. Chump change, cheap car. And let's say that it depreciates at 10.5%. We're going to find the value after 5 years. A 10.5 is actually not very much for a car. That's such a nice car, it doesn't depreciate as fast. Most cars will depreciate 18 to 20%. So the way you would set this up is the same way with the formula earlier. We started with the principal being the initial amount. Okay, we're going to do the same thing here. We're going to start with the initial amount. So you can say A equals whatever. The initial amount is $87,985. We're going to open parentheses. Everything works off of 1, meaning 100%. Because this car depreciates, I need to subtract from 100%. So I'm going to subtract 0.105. Then we can do that to the x. So I can take this 5 and I can plug it in right there, and you would get $50,527.04. That's how much your M5 is worth after 5 years. So play with that a little bit. If you were talking about something that appreciates, sometimes homes, not lately in this economy, but sometimes homes will appreciate. So if it's appreciation, then you would add the percentage to 1, and you could work at it from there. But that pretty much does it for today's lesson. So your assignment is on the board. Homework 1A, page 226. It is due tomorrow on Thursday, so make sure you get that, and I will see you back here tomorrow. Thanks.